In this video, I'm going to explain how to draw a displacement graphically, and we'll also be learning how to add together more than one displacement vector. So be sure you have your handout printed, you need a ruler, protractor, and you'll also need graph paper once we get to number 2. So number 1 says, suppose a person is on a walk and has a displacement of 60 meters at this direction, 30 degrees north of west. How can we draw this displacement? Whenever you're going to draw a displacement, you need to have a coordinate system. And it's actually true for drawing any kind of a vector. And a vector is anything that can be represented by an arrow. So displacement has a direction and a magnitude, so it can be represented by an arrow. The same thing is true of force. The same thing is true of velocity. An example of something that cannot be represented by an arrow would be the quantity of mass. Because mass only has magnitude, it doesn't have any kind of a direction in space. So we know that our displacement has a magnitude of 60 meters and has a direction of 30 degrees north of west. First, let's figure out how to do the direction. Over here I have a coordinate system, and you always want to sketch a little coordinate system. The type of coordinate system you draw or how you label it will depend on how you are given the direction or how you want to state the direction. Here we're given information about north and west, so I'm going to label this as north, east, south, west. And the angle is 30 degrees north of west. So what we do is we find west, and it says it's north of west. So from the west direction, you could go southward or you could go northward. Here it says north of west, so start at west, and we're going to need to go northward 30 degrees. So we need to have a protractor. So line up that center point of your protractor on the center of your coordinate system. And then I'm going to count sort of the degrees on my protractor. So starting from here, starting from west, I'm going 10 degrees, 20 degrees, 30 degrees. And I'm going to put a little mark on the paper where that is. And now I'm going to draw just a little line to show where that direction is. Okay, so my arrow is going to be along that line in that direction, but I don't know how long it should be yet. So now we're going to draw the length of that arrow. We're going to put an arrow there, we're going to draw it to scale. It is not possible for me to draw an arrow that is 60 meters long. That just wouldn't even fit in my house. So I'm going to have to set up a scale. And when you set up your scale, you want to think of something that would be drawable on a paper. So, your paper is about 21 centimeters wide. It's about 28 centimeters long. So think about those numbers when you pick your scale. I'm going to think of having 1 centimeter on my drawing represent, we could have it represent 6 meters, or you could have it represent 10 meters. Let's do that. So now I need to figure out how long of an arrow do I need to draw for 60 meters if this is my scale. And you might be able to do this in your head, but it's not always easy to do it in your head, so I'll show you how to do it. So my displacement is 60 meters, and I'm going to multiply by this conversion factor, my scale. I want the meters to cancel out, so for my scale I'm going to put the meters on the bottom so that those will cancel out, and centimeters on top. Then the meters cancel out, and 60 divided by 10 is 6. 6 times 1 centimeter is 6 centimeters. So that tells me that my arrow needs to be 6 centimeters long. And fortunately, that is barely going to fit on my paper. So starting here, whenever you draw a vector, always start at your coordinate system where you're measuring the angle and draw your arrow. And I need to make it 6 centimeters long, so it's going to stop right here. And this now is the displacement vector that represents 60 meters at 30 degrees north of west using this scale. It's important with a vector to know the parts of it. So let's just give them labels. This end of the arrow is called the tail, and this end of the arrow is called the tip. Always measure angles at the tail. Never measure angles at the tip if you're trying to draw a vector, or if you're trying to measure the angle of a vector.